Hello, my name is Aileen Perez and my partner Jorge Figueras, and today we are going to be presenting the Phase 3 of our Capstone project, Functional Finger Prosthetic Design. In the outline we have system validation, validation objective, verification and validation of MOPs, and verification experiments. We have the complete system budget and project planning. Validation objective. The goal of this project is to design a powered assistive device for partial finger amputations. With the use of motors and sensors, get the hand to do daily tests. These motors will work in tandem with the feedback of a lightweight rechargeable battery and have a force of 2 kg force or more. Verification and validation of MOPs of the entire system. Material should be high quality. There will be verification type. Should be quick to recharge, verification. Weight should be less than 5 pounds, verification. Material should be low cost, less than 150, verification. Will low sale cost 250, verification. Should have long use of batteries, at least 8 hours, verification, and the patient should be able to put it on alone. That will be validation. Verification and validation of MOPs of the control system. Sensor motorized must fit on 5 to 6 centimeters diameter of skin. Verification. Sensor electrode should captive 100 millivolts action potential. Verification. Circuit should be reliable to send 5 volts to the motor. Verification. Microcontroller must work with 0 to 5 volt input and output. Validation. Torque of the servo motors should be greater than 100. Validation. And must have good wire connectors to send 100 millivolts efficient at the circuit. Validation. Verification and validation of MOPs of mechanical design and activation. High durability of the materials, that is verification type, resist temperatures of 120 Fahrenheit, verification, can lift objects of at least 5 pounds, validation, make a fist and 3-finger shock grip, validation, and caters to partial hand amputation patients, validation.
Here we have the verification experiments. Experiment 1 will be for MOPs to verify 4 and 5 that are related to the cost. We'll be doing open the web browser and look for each of the pieces and materials that are on the list for the creation of this prosthesis and make sure that the price are those indicated in the information that we have. Then we'll be making an analysis and comparison of other prostheses that are similar. The experiment number 2 will be verifying the MOPs 1, 14, and 15 that are related to the materials. For this experiment, we'll be open the web browser and do a detailed search of the materials used in the creation of this prosthesis, make sure that they meet the quality that they must meet. For the experiment 3, the MOPs to verify are number 2 and 6 that are related to the battery. We'll be doing open the web browser and look for a study on how the batteries are recharged quickly. After analyzing how it works, see if the chosen batteries comply with that article. Experiment number 4, the MOPs to verify are 8, 9, 10, 11, 12, and 13 that are related to the controls. We'll be doing a simulation of the circuit to get all the values that we need in order to make the circuit comply with all the MOPs. Here we have the validation experiment, that is experiment number 5. The MOPs to verify are number 3, number 7, 16, 17, and 18 that are related to the mechanism. For this experiment, we will transfer the files of the design of the prosthesis to a VR to do a simulation testing of how it will be to put the prosthesis with only one hand. Then we will be doing a search for studies related to the force and the types of grips of the power prosthesis to check and calculate that the values that we predicted are correct. Here we have the system budget, that the total cost of the entire system is 164 with 84 cents, that is on budget. And finally we have the project plan that will be presenting phase F in March 17 of this year. Thank you.